Hi, my name is Majed Khalaf, and for my fuel science presentation, I decided to do the landfill gas-to-energy project. Firstly, what is a landfill? A landfill is a location in which waste materials are sent from various places. There are three main types of landfills, each to hold the various types of waste. Firstly, we have municipal solid waste landfills, industrial waste landfills, and we have hazardous waste landfills, in which municipal solid waste landfills are used for disposing household waste, such as discarded food items or packaging. We have industrial waste landfills, which are used for disposed commercial or institutional waste, such, for example, a university library. And finally, we have hazardous waste landfills, which are used for disposed specialty waste that has the potential to be harmful. For example, radioactive waste or biohazardous waste from a hospital, such as injection needles, etc. For the landfill gas energy project, we're focusing on the municipal solid waste landfills, as this is the type of landfills that actually contain the most organic material which we are allowed to siphon the more useful gas out of. And so this brings us into the composition and the origin of landfill gas. So landfill gas is a byproduct of the microbial decomposition of organic waste materials in MSW. Landfill gas is roughly composed of 40 to 60% methane gas, where the remainder is carbon dioxide, which is another byproduct of this microbial decomposition. Now, the microbial decomposition is broken down into two steps, the aerobic and the anaerobic decomposition. For the first stage, when the MSW is initially disposed into a landfill, the waste undergoes aerobic decomposition. This stage, more carbon dioxide is produced than methane. Carbon dioxide is the main product, where little amounts of methane are generated. Aerobic meaning that the microbes are respiring oxygen in order to break down these materials. And for the second step, over time, anaerobic conditions start to form, and therefore anaerobic decomposition starts to occur. And in this stage, more methane is produced while carbon dioxide is also still generated, but in much smaller amounts relative to the first stage. Anaerobic meaning no use of oxygen, a lack of oxygen. Now, what is the usefulness of the landfill gas? The methane that landfill gas contains is a very valuable resource that we are able to recycle and then convert into energy. The methane is typically disposed of by being released into the atmosphere, and as we know, methane is a greenhouse gas, and so emitting it into the atmosphere is not an ideal situation. Landfill gas to energy utilizes this methane by diverting it into an on-site treatment plant where this gas can be then converted into energy. A system of vertical wells and pipelines siphon that methane gas from the landfill gas that is produced from the municipal solid waste landfills. To convert this methane into energy, it is a simple combustion process in which it is burnt to produce heat or generate electricity. As we can see here, we have a typical schematic of a generic landfill gas to energy project, in which here we have the municipal solid waste landfill, where landfill gas does form. These vertical gas collection wells siphon this landfill gas, and then it is sent into a gas extraction and cleaning equipment site, in which that methane can be separated from the other materials such as carbon dioxide. And then it gets put into a gas engine and electric generator through the transformer and then to the grid, and then we have clean energy. And now we have advantages and disadvantages of methane from landfill gas. One of the advantages is that there is a reduced impact on the environment. As aforementioned, this methane, or this landfill gas rather, is actually just emitted or released into the atmosphere if nothing is done with it. And so a gas to energy project allows us to do something with this gas, and it's actually something very, very useful. As we can see, we had clean energy. This methane siphoned out of the landfill gas can also supplement or replace existing natural gas usage in the electrical grid. For example, if there was a shortage on natural gas, we can actually use this methane to supplement for it and replace it. And there is really one big, I'd say, disadvantage of landfill gas, in the sense that it is preventable. However, it is pretty difficult to prevent. And that is non-organic or non-biodegradable materials, such as plastics, can potentially carry harmful halogenated chemicals, and that these chemicals can be combusted with the methane or anything like that, and that could potentially pose problems to the environment with having these different types of gases entering the atmosphere. Again, this is preventable, and this is preventable by having municipal solid waste that is solely used to waste material that is purely biodegradable, such as compost. And we're talking things such as cardboard, things such as just food items, that sort. Anything fibrous materials, etc. And so we also have other conversion products from the landfill gas that either come from the methane or the carbon dioxide, which is also another reason why this landfill gas is also very useful. And so most of the time the methane is used to be burnt for its energy, as we saw previously, the landfill gas energy project, but the methane can also undergo different processes to have different outcomes. Moreover, the carbon dioxide content with it. Firstly, the methane from landfill gas can also be used in boilers to generate heat, gas turbines to generate electricity, fuel cells to generate electricity, and conversion from methane into methanol, in which this methanol can be used to get energy out of it itself, or this methanol can even be used in fuel cells. So these things actually intertwine with one another and they link. Now, the carbon dioxide from landfill gas can be used, but only really right now there is no particular use for it in the energy industry, such that this carbon dioxide siphoned out of the landfill gas could be used to create dry ice, for example. And this isn't a very sought out after method of producing dry ice because it's not a very effective way of producing carbon dioxide. As we can see, this carbon dioxide is produced as a byproduct of human waste. And that brings me to the conclusion of my presentation. Thank you.